Well, it all started so simply, just Einstein assuming that all observers are going to measure the same velocity for light in every direction, thereby preserving relativity, and gave birth to the theory of special relativity, which seemed pretty simple, but out of that came weird things like time dilating and events that aren't simultaneous anymore, and we can't agree on length anymore. If you thought that was weird enough, we're going to have a look at what happens with mass and energy, and it comes out of the mass dilation formula, which we've already seen where that comes from. And what it essentially means is the faster that we go, the greater our inertial mass appears to come. So if something's moving with a velocity relative to you, the closer that velocity gets to the speed of light, the more its mass increases. Well, we never normally see this because the kind of velocities that we can normally achieve, even with rockets down here, our inertial mass is equal to our ordinary mass, and nothing really happens. But as we get closer and closer to the speed of light, you can see that graph tending upwards, and it actually ends up, as we approach the speed of light, our mass increases to infinity. So what effect is that going to have upon a spacecraft? Well, we accelerate spacecrafts by turning chemical energy or another form of energy into kinetic energy. We add energy, we do work by applying a force on a spacecraft. And that increases the kinetic energy, and the kinetic energy is the mass times the square of the velocity. But as we get closer to the speed of light, because the mass increases incredibly, then the force has to increase, and the amount of energy we're putting in becomes enormous. We're putting in a huge amount of energy, and we're getting very little increase in velocity. So where's that extra energy going? Well, even if we allow for the mass dilation in kinetic energy as a half mv squared, that still doesn't account for all of the energy that we're putting in. And what Einstein realised is that the total energy of an object is equal to its kinetic energy plus something else. Well, if we look at kinetic energy, what we can see is that energy is proportional to mv squared. So what Einstein hypothesised was that that extra energy is mc squared. Now, we don't have the mathematics, and it's way beyond the scope of this course to try and show exactly where that came from. But it has some really fascinating implications, and that is when an object is at rest compared to you, in other words, there's no kinetic energy, E equals mc squared. And what that means is that energy and mass are equivalent. Now, that might not sound much, but that rocked the world. You see, up until now, we believed that mass was always conserved. In any chemical reaction, the mass of your reactants equals the mass of your products. There's no mass lost. You can't make or destroy matter. And the same law of conservation applied to energy, that the amount of energy that you have is the same. You can turn it from one form into another, but you can't create or destroy energy. E equals mc squared turned all that around and said, well, actually, no. Energy can hide as mass, and mass can be converted back into energy. There's an equivalence between mass and energy. And the equivalence is enormous because c, the speed of light, which is 3 times 10 to the 8 metres per second, is an incredibly big number. So when we square it, we get a fabulously large number. So it means the tiniest amount of mass change gives rise to a huge amount of energy. So we're not normally able to measure the change in mass. It applies to a lot of things, even to this pen here. This pen actually has a tiny bit more mass up here than it does down here, corresponding to its greater gravitational potential energy. Of course, the amount of energy is tiny, and therefore the amount of mass increase is immeasurably small. Yet this has real implications. Every single nuclear weapon, every single nuclear power station runs on E equals mc squared. We undergo reactions where the mass of the reactants is greater than the mass of the products. We lose some mass somewhere in that reaction, and that mass gets converted directly into energy. So the tiniest loss of mass gives rise to this enormous amount of energy. And of course, even though it took us Einstein to see this, this has been staring us in the face since we first opened our eyes, because the sunlight that we receive, that energy we receive, comes from E equals mc squared. Nuclear reactions on the sun are destroying matter in the sun and turning that matter directly into energy. And so pretty much everything that we do, the energy that you're expending right now, has come from plants that you've eaten, and the plants have got that from photosynthesis, from the sunlight. So in a sense, you are running on nuclear energy. So E equals mc squared is probably one of the most significant outcomes of the theory of special relativity, the equivalence of mass and energy.